So this video discusses about solving the logarithmic equations using what we call as the substitution method. And the basis of this concept requires you to understand about solving the logarithmic equations and also solving the exponential equations. It also requires the concept of solving the quadratic equations, either the factor method, completing square method, and also even the quadratic formula. So and also you need to understand about the laws of indices and some concepts that are very important to make use of. Now let's say we have the following cases. Let's say we have the case whereby you have, let's say, 3 to the power 2x, and let's say minus 7 3 to the power x, like that, and let's say is given as the negative 10. So how do you think we should have to solve for x in this point? So first thing, we should have to reduce this to quadratic actual equation, in the sense that we have it as 3 to the power x times to the power 2, and the minus 7, that is 3 to the power x plus 10, which is equal to 0. Then we should have to let 3 to the power x being equal to, let's say, being given as m. So at this point we have it as m to the power 2 minus 7 m, which is plus 10 will be equal to 0. Then let's see if m can be solved using the factor method. So as it stands here, it is possible to solve for m using the factor method. That will be given as something like that. We'll have that and as plus 10 is equal to 0. We'll have to pair up this. So at that point we'll have, what is the common factor for the first pair? We have it as m minus 2, and that the common factor for the second pair is given as negative 5, which is m minus 2. That will be equal to 0. So make sure you understand about factorization. The factor method of quadratic, how to factorize the quadratic equations. So in this case we'll have it as m minus 2 times m minus 5. That will be equal to 0. Then you have m being given as 2, and you have m being given as should be 5. So that is. But our equation is in form of x, not as m, so we should have to substitute back. So at that point, so have for m is equal to 2. Then we'll substitute back here, we'll have 3 to the power x, which is equal to, should be 2. So how do you think we can solve for x here? How do you think we can solve for x here? So it should be 3 to the power x. So how do you think x can be obtained at this point? So as you can see the basis, keep in mind that this is the same as having it as 3 to the power x, which is the same as 2 to the power 1. As you can see the bases are different, but we cannot even express the bases to be the same. So the only way is to introduce log, in other words, to use the logarithmic method. So where I will be introducing log both sides, we'll have log 3 to the power x, which is equal to log 2, and just that. Then using the properties of the logarithms, we'll have it as x here, and log 3 is equal, and that should be log 2. Then we'll have to divide both sides by log key. Actually that will be given as log 2 divided by log 3. That is, and you can proceed that one using your calculator. You have it. And also for m is equal to, let's say, 3, should be 5. So this point we'll have it as 3 to the power x, which is equal to 5. So as you can see, we cannot express 3 and 5 to have the same base. hence we'll use the log. So we'll have to introduce log. We'll have log 3 to the power x, that is the same as log 5. Then we'll have it as x log 3, that is the same as, should be log 5. Then we'll have to divide both sides by log 3, that will be given as log 5 divided by, should be log 3. So we'll have that, and we'll express that. We'll complete those using our calculators, either the 2 or 3 decimal places. And how about, let's say, if we have something like this? Let's say if we have, and should be, let's say, 5 to the power, let's say, 2x. It has to be minus, let's say, 13 and 5 to the power x. Let's say that is the case, in plus, let's say, 40. So how do you think we can solve for x at this point? So in this point, we'll have it as, using the laws of indices, we'll have it as 5 to the power x, and our overall to the power should be 2, and the minus 13, 5 to the power x, and the plus 40, which is the same as L. Then I'll have to let 5 to the power x, let's say, being given as y. So have it as that. So which means we'll have it as y squared minus, let's say, 13y, and a plus 40 like that, and which is equal to 0. Then how should you have, to factorize this? So in this case, this is the same as having it as y squared, and that should be minus 8x, minus 5 should be minus 8y, not x. So minus, 8y minus should be 5y in the plus 40, which is equal to 0. Then have it as y should be minus 8, like that, and the minus 5, y minus should be 8, which is equal to 0. So that is y minus 8 times, that is y minus 5 at this point, like that. And the y is given as 8, and also the y is given as, and that should be 5. So at this point, we'll have it as, we should have that one as, now we'll substitute back so for x. So in this case, we'll have it as, for y is equal to, let's say, 8, then we'll have it as, should be 8 is equal, 5 to the power x. So as you can see, the bases can't be expressed to be the same, hence we're going to use the log as well. So have to introduce log both sides, or have log 5 to the power x. That is the same as, so have it as log 8 is equal to x log 5. So that is, we shall have something about, so in this case we'll have it as, we'll have to divide both sides by log 5, or have it as, should be log 8 divided by, and that should be log 5. So that is the value of x. You should have to get it up, and using the other value, that is for y is equal to 5, it means we'll have it as 5 is equal, 5 to the power x. So in this case, since the bases are the same, then you just have to equate the powers. So have it as 1. No need to use the log there, because exponential, can use the exponential technique to solve f of x there. And also try to have this, and also try to see how you can make the following things up. So in this case, let's say if we have, let's say if we have, let's say 2 to the power 2x, and let's say minus 5, that one in the 2 to the power x, and plus 6. So try to solve for x in this point and appreciate how you can have it. And let's say if we can have, let's say, something about, if we can have, let's say, 5 to the power 2x, and that should be plus, let's say, 3 to the power 5 to the power x, and which is equal to, and that should be positive. That has to be positive. Let's say positive 6. So try to solve for x at that point, like that. And how can we have this one as well and appreciate? Let's say if we have, something about, let's say if we have, let's say, log of, let's say, 3x, log 3 of x, and let's say plus 2, and we have, by the way, we should use log 4 here. We should have, let's say, log 4 of x. Let's say log 4 of x, and plus 2 of, let's say, log 4 of x, and which is equal to 3. So how do you think this one can be solved? So as you can see, this equation, this is logarithmic equation, but it is not in actually, it is not as the linear equation, because the linear equation, in this case, the way it is here, it is the same way you can depict as, you can see it as x plus 2 over x is equal to 3. So this is not part of the linear equation. But if we could have had, let's say, it as, if we can have, let's say, x plus x over 2 is equal to 3, this is the linear equation. But as it stands there, that one is no longer a linear equation. So at that point we use the substitution method. So in this case we'll have to write, log 4 of x being equal to, let's say, m. So in this case we'll have it as m, plus 2 over m, that will be equal to 3. So in this case we'll have to solve for x. We're going to, multiply everything by m to eliminate the denominator. That will be given as the m square plus 2, which is equal to 3m. So in this case we'll have it as m square minus 3m plus 2, that is the same as l. Then in this case there's actually a factor method to work. We'll have it as m square minus m minus 2m and plus 2, which is equal to 0. That will be given as, m minus 1 and minus 2 m minus 1, that is equal to 0. So have m minus 1 times, that is m minus 2, that is equal to 0. So in this point we have m is equal to 1 and also m is equal to 2, as you can see. Then I need to substitute back and for log 4 of x. So what do you think will be that? So in this case, for m is equal to 1, then we'll have it as, log 4 of x, that will be equal to 1, and from here you can be able to solve for x. And also for actually m is equal to 2, we'll have it as, log 4 of x, that will be equal to 2, and from this point you can also be able to solve for x. So keep that in mind. And how about, let's say, if we have something like this? Let's say if we have, and that should be, let's say, log 3 of x, and has to be plus, let's say, 3 over, let's say, log 3 of x, and which is equal to 4. How should you have to solve for x there? And also try this one as well. How about if, let's say, if we have 4 log, let's say, 3 of x, which is equal to, let's say, 9 over should be log 3 of x. So how do you think you can have that? So try to practice those questions and appreciate how you can have it. So that's how we solve the actually logarithmic equations using the substitution method. Thank you.